Uh, Now we are going to discuss about the dielectrics and our insulators and what happen when a dielectric or insulator is placed on an electric field. In the last video, I have told you something about what happened when the uh, conductor is placed in the electric field. Okay, we just have a little glance that what happened when the conductor is placed in an electric field. Just imagine this is a conductor and this is an electric field. Okay, so the conductors are having more number of free electrons. Suppose if it is having positive electric field, okay, all the negative charges will be aligned in the conductor and all the positive charges will be aligned here opposite side. So inside the conductor it experience some induced electric field, and outside we have external electric field. Now as a result, when I place a conductor in an electric field, what happened, this external electric field will become equal to induced electric field where inside the conductor. So what happened, the sum of, and especially the induced electric field will be in the direction opposite to the external electric field. So if induced electric field will be acting in this direction, okay, the external electric field will be acting this direction. Okay, so at inside the conductor the electric field will become 0. Okay, so this is a conductor. When I place in a electric field, inside the electric field will be 0. When the electric field will be 0, automatically the charge will be 0. Charge will be 0. Okay, when the charge will be 0 means the potential inside is going to be constant. The potential inside the conductor to bring a charge from one point to another will be a constant. Right, this is what we have seen in the last video. Now what happened when a dielectric or insulator will be placed in electric field? Okay, first of all we have to see what is dielectric and what is an insulator. What is an insulator? We may know that when a conductor or a material will not have the capacity to allow the electrons to pass through it, then it is called a insulator. Okay, especially it should not have the ability to allow the current to pass through it. Okay, right. Now so here insulator will have two different types. Let us see the first two types, non-polar molecule and polar molecule. A very important difference between polar molecule and non-polar molecule will be the centers of positive and negative charges will be coincide, and it has a permanent dipole moment. Okay, so these two are the very important point for the non-polar molecules. The first one is the centers of positive and negative charges coincide. So when it is being coincide, it cannot have a permanent dipole moment. So it has no permanent dipole moment. The examples of non-polar molecules are hydrogen, oxygen and carbon dioxide. Okay, then the next one is polar molecule. What is polar molecule? The centers of positive and negative charges will be separated. So due to when it is being separated, it have a permanent dipole moment. Okay, so these two are the important point for the polar molecule and non-polar molecule. Okay, so there will be a connection between polar molecule and non-polar molecule, and also the dielectric and also the insulator, because polar and non-polar molecule will also come under insulator and also the dielectric. Okay, the examples of polar molecules has given. Okay, right. Now so what happened when an external field is applied? So when a non-polar molecule will not have a dipole moment, when the external field is applied, remember the centers of positive and negative charges separated. Okay, so this will create or induces a dipole moment in the direction of the external electric field. So then the dielectric is said to be polarized by an external electric field. When a non-polar molecule is placed in an electric field, okay, it produces some polarization. Due to that polarization, okay, it created some electric field inside the conductor, inside the dielectric. Remember, in a conductor, when it is placed in an electric field, inside the electric field is 0. But for the dielectric or the non-polar molecule, when it is placed in an electric field, it has certain electric field. Okay, so this diagram will show you easily Okay, like uh, see, look at the picture. There is a polar molecule is placed in an electric field. Okay, in the absence of, look at the first diagram, this is the absence of electric field. In the absence of electric field, all the dipole moment will be randomly aligned. See, you can find one thing in a conductor. We didn't give the dipole. We have simply gave the charges. But for the but for the insulator, but for the polar molecule, but for the dielectric, we have mentioned the dipole. Why? Because in a conductor, it has large number of free electrons. But here, it will be having combined with neighboring charge or opposite charge. Okay, so here it is having in the form of pair, in the form of dipole. Okay, so for the polar molecule, when it is randomly oriented, if we cannot have any particular direction of electric field, so at in the absence of electric field or the net electric field will be 0. In the absence of electric field, in a dielectric, E is equal to 0. When I have placed in an electric field, okay, what happened when I have placed in the electric field? Okay, so here all the negative charges will be aligned here, and all the positive charges will be aligned there. Okay, so it creates some electric field in the direction opposite to the external field. Likewise, what happened for the conductor? But the thing is, in the conductor, the external electric field and induced electric field will be equal in magnitude and opposite direction. Here, equal in direction, opposite in direction, but not in equal. Okay, so look at the diagram. So in that diagram, so this is the central point. This is the central point, and up to here, it is a induced or internal electric field. Up to here, this is external electric field. Obviously, okay, so we have, okay, obviously we have the external electric field will be greater than the internal electric field. So due to that, it is creating some polarization. Due to the polarization, it creates some external force. Okay, so now this is polarization. Actually, this is very important point. The polarization is define the number of total dipole moment per unit volume of a dielectric. Okay, right, here P is directly proportional to electric field and psi is called the susceptibility. Okay, right. Now we can come to the conclusion that what happened when a dielectric is placed in an electric field and a conductor is placed in an electric field. When a conductor is placed in an electric field, okay, the inside there is no electric field. Okay, when a conductor is placed in an electric field, inside the conductor, okay, both will be getting cancelled, so there is no external electric field. But for the insulator, when it is placed in an electric field, it is not 0. Okay, the electric field inside is not 0. Okay, due to that, what will be the result we can have? Okay, so the balloon is called as an insulator. We can take us as a dielectric. Okay, when a dielectric initially when it is being rubbed, okay, it has created certain electric field. Due to the electric field, it is getting some force. Okay, due to that force, when I am placing near the wall, okay, it will be sticking. Now we can see the diagram. So the same experience we can have when I rub the plastic sheet, or when I rub the pit balls or a palmolene ball. Okay, so this will be sticky when it is rubbed or when it is getting disturbed. Okay, so this is the conclusion. What happened when a conductor is placed in an electric field, when an insulator is placed in an electric field. Okay, thank you.